thanks for coming and thanks for watching. The first talk we have today is by Orla. She's the manager of the infrastructure team in HEAnet, and she'll be doing a talk on do you know where your internet comes from and how DCU connects to the network as a whole.
Okay.
Thank you.
Thank you. So, hi, as Orkin says, my name's Orla. I'm the Infrastructure Services Manager in HEAnet. Who am I? Well, once upon a time, I was a student here in DCU. I did electronic engineering in DCU back in the days when this was our logo. I was a member of Redbrick, and I was a committee member of Redbrick back in the days. I was the entertainment officer in... And when I was leaving, DCU graciously upgraded us to the Zanussi logo, and that's what's on my degree. After that, I left and I went working in HEAnet, and then I came back to study in a research group, a networking research group called CNRI, which was based in DIT. And then I moved to the Hamilton Institute, which is another networking research institution based out in NUI Maynooth, and I got my master's from NUI Maynooth. So that's a little bit about me. What else about me? If you know me or know anything about me, you know I've been in HEAnet a very long time. And when I was preparing this talk hastily yesterday, I, for amusement, had a look at what our logo used to look like when I joined HEAnet back in the days, and it looks like something out of the dark ages. But I assure you I'm not that old. But we've progressed over time from this gem, which, by the way, was an animated GIF on our website back in the day, just for total awesomeness. Progressed here to our purple and winey coloured one, and now we're back in sick, cool navy as of this moment. I think it's probably time for a logo upgrade, but I'll be killed for saying that. And while digging through the archives, I discovered this, which frankly is just comedy gold. Here's what we were advertising as our services back in the year 2000. So we've got fibre optics, a CRT monitor, a satellite dish, and my personal favourite, an old-fashioned clickety keyboard, which are all gone the way of the dodo at this stage. So who are HEAnet? You're all here connected to the internet, and you probably have no clue how that is happening or why that is happening. We are the National Research and Education Network for Ireland. It's called an NREN. That term is used a lot in our line of work. What that means is we provide internet connectivity to all of the universities, Institute of Technologies, primary and secondary schools, and basically anyone and anything related to education that's publicly funded in Ireland is eligible to take our services. So we have a bunch of different clients that you may or may not have heard of: the CAO, DIAS, which is the Dublin Institute of Advanced Studies, EPA, iCheck, which is the Irish Centre for High-End Computing, ESRI. We have lots of clients, 60 odd as far as I remember. So it wouldn't be a talk about networking without a network map, and I'm going to dazzle you with all of these. So this is a view of the state of our network as it currently is, or as it was yesterday at 10:27 a.m. So as you can see, we have all of our clients connected in. They are connected into our core POP here in City West. We have a backup POP in Park West, and all of the traffic primarily is routed out of City West, and if anything happened to that core router, it would fail over to Park West. We can opt, obviously, to have routing going from either place, and we control that. And I said, why? Just because I'm giving a talk in DCU, is DCU here sticking out like a sore thumb on the back of Blink? So I was told that they had asked to swap over for some routing reason that I said, okay, whatever. But obviously you're all interested in networking, so what's interesting, I suppose, about this is it just allows us to see at a glance if any of our clients are hitting their maximum capacity of their links. So you can see the EPA is up there at about 90% usage at a glance. It also gives us visibility over here of our transit and peering links. Do you know what transit and peering links are? Have you ever heard of this? So we're an ISP, and ISPs get their internet connectivity from Tier 1 internet service providers. So we go out to the market and we procure internet connectivity from these companies. So at the moment, as of our most recent tender, we have Level 3 and GTT. And then, so transit is internet that you pay for, like a phone bill. And peering is where you exchange your routing prefixes for free with the other party. So it's of interest to the academic and research community to want to talk to the universities that HEAnet provides access to. So we send them our prefixes and they send us theirs. The same thing happens with level 3 and GTT. We just pay them for that piece of the puzzle. HEAnet is the pan-European network, which I'll explain in a minute, of NRENs. And INEX is the Irish Neutral Internet Exchange. So that's where every ISP in Ireland gets together and meets and shares their routing information and prefixes so that the traffic doesn't have to go out to the general internet and come in over costly links. So it's basically a way of saving money, which is very important. HEAnet was a founding member of INEX back in '95, I think, if I recall correctly. And the whole idea at the time was we had monopolies like Telecom Éireann, I think it was still Telecom Éireann at that point, charging a small fortune, sending their traffic over to the UK via cable and wireless link, and we were paying for a return link through cable and wireless to come back to talk to people on their dial-up connections in 1995 for internet access. So if you wanted to access the internet from home and you wanted to contact the computer in DCU, it was taking this very long circuitous route over the Irish Sea. So that's why we have peering and that's why we have transit. Does that make sense?
Yes.
So I guess this is the bit that maybe goes a little bit unnoticed or ununderstood for what HEAnet does. At its core, we connect the universities and the colleges and all of that to our backbone network. So we have a dark fibre ring network in Dublin and also as a figure of 8 around the country, all over Ireland. It's hard to see it here in that description, but basically this is the Dublin fibre ring and this is the rest of Ireland. And what we have is a collection of dark fibre links that we light as an optical network from different fibre providers. So primarily the backbone, the national backbone network around the country is ESBT fibre. We leverage the fibre that the ESB telecoms wrapped around all of the high voltage wires around the country, which is really cool. And then the government, I don't know, I think around 2005 or so, started putting metropolitan area networks in the regional cities because it wasn't commercially viable for fibre companies to go do that. So the government paid to do it. So those are operated by a company called HEAnet, and there we have the one in Galway, the one in Limerick, the one in Cork, and the one in Waterford. And we use that fibre to connect UCC, WIT, UL, and all the clients that are in those regions. So at a glance, when we have a networking fault, we look at this map and we can say, okay, there's a problem between DCU and Trinity, and DCU is one of our core POPs. We connect in other clients here at an optical and at a layer 2 level. So you can see IT Blanchardstown connects in there, and also our data centre out in Blanchardstown is in this ring. And obviously DCU connects in here, and so do the DCU colleges of St. Pat's and Mater Dei. And I can see all the fibre that connects all of those. Does that make sense? So this is one of my favourite maps. We designed it based on the iconography of the London Underground system, so it makes it nice and clear. It's quite hard to translate this kind of physical information into a logical map that makes sense easy for troubleshooting, but I think we've managed to do this quite well over the last 10 years or so. So I mentioned HEAnet, and what HEAnet is the collection of European NRENs getting together and having a network to connect us all together. So it's our own bit of the internet. So here's a map of Europe, oddly enough, and all of the fibre links that connect the HEAnet, different NRENs that are connected through HEAnet. So we have direct links to the UK. One is 10 gigabit and one is a lit fibre. Actually, this is a bit old. I think they're both dark fibre links now that we light. Happens to be at 10 gigabits, but we have multiple 10 gigabits, so I think it's 20 gigs in total to Paris and to the UK. So I guess this is just something that, again, people don't really realise is there. We do a lot of cool projects with HEAnet through European funding that allows us to do things like make direct connections from a university here in Ireland through to Switzerland for people who work in CERN on the Large Hadron Collider or whatever they're up to these days. So we can enable that kind of project work and connectivity directly through our network through HEAnet. And it's all high speed and there's low latency and all of these things that we just expect and other people don't realise, I suppose, are there. So how does this look from a traffic profiling point of view? This is a piece of software called NFSen, and it uses a tool called NetFlow to sample traffic to basically allow us to see exactly what's going on in the network on a packet-by-packet basis, on a bit-by-bit basis. So this is all of our traffic as of the week, taken yesterday, so yesterday morning. And you can see this is an aggregate graph of all of our peering and all of our transit. So it's everything that's coming in and out of the HEAnet network to the internet. So we have peaking at about 25 gigs across all of it out and about 5 gigs in. So what are you doing with all this internet bandwidth? Well, largely Facebook, it seems. Well, I decided not to single out DCU here and really drive home the point, but as you can see, it's a large amount of traffic that goes to Facebook from the HEAnet network. Peaks at about nearly 2 gigs daily, which is considerable. It's going mainly, as you can see, via our HEAnet link, so the light blue colour. So that's good for us. That means we're not paying for it, so that's great. We're peering. Twitter is also very popular, but I guess not as popular because it's an order of magnitude less. We're talking megabits here instead of gigabits. And then there's Netflix. I mean, really, do you do anything here at all? No studying? Apparently not. It peaked yesterday while I was looking at this. So, I don't know. Yeah. So it's quite cool to be able to visualize the network in this way. I mean, graphs are obviously highly attractive and interesting to everybody, but I think it's quite cool to be able to dig down and see exactly what's going on the network and see what's happening. And then something that's close to my heart and I feel totally vindicated for as of this morning, which I'll explain in a minute. This is our aggregate IPv6 transit and peer traffic. So it's a lot lower, obviously, than the gigabits, the 25 gigabits of aggregate IPv4 traffic, and I should have said that was only the IPv4 traffic I showed you previously. Down here you'll see a lot of the dark green. That's pretty much mostly FTP traffic. So we get a lot of IPv6 FTP traffic. We host an FTP server, which most people are familiar with. That's where you get your free software upgrades from, generally when you're on this island. As of this morning, I had a delightful morning. Our mail server went down and it was assumed it was a routing problem, and I had to do a lot of troubleshooting right before coming here, which was great. We literally ran out the door 20 minutes before we were supposed to have this talk. But the interesting part of all of that was while IPv4 was broken to the mail server, IPv6 was working perfectly. And why that's a joy to me is because I'm the person who set up the IPv6 network in HEAnet many moons ago, and I'm constantly told how it's never going to take off and it's a waste of time, and yet here it is. The only way that we had mail today was through IPv6, so in your face. So what does HEAnet do on top of the connectivity? So connectivity is just taken as read now. You know, when I joined HEAnet, that was the most important thing. The NOC's main bread and butter was troubleshooting link connectivity issues. If there was a problem with an Aircom link connecting UCC back to HEAnet in Dublin, we had to follow up on that and deal with the provider. Now, as I said, we run that optical link, so if there's a problem with the circuit, we have to look into it. It's a problem with our transmission equipment, unless somebody's driven a JCB or something, tried to rip out fibre thinking it was copper to be resold on. These are typically the problems we have these days. But on top of that now, what we do is we provide a lot of services to the education community. These are ones that you may or may not have heard of. First one there is we do a hosted Moodle service, so loop.dcu.ie is hosted in HEAnet, and we look after all of that, for better or for worse. And EduRoam, and Lorcan warned me that this is going to be a thorny subject, but what EduRoam is, I will be very clear, is a federated Wi-Fi service, and federation is, it allows you to use Edugate, which is our single sign-on federation service, so you have one log on for all of services in DCU. That is not how it used to be, people. You used to have to remember 20 different passwords depending on whether you were sitting in the library or in the CS labs or in the engineering labs. Now you have one identity that is used across all systems, and that's powered through Educate, which is the federation, and we use protocols like Simple SAML and Shibboleth, and some people use ADFS to do that. What EduRoam is it's taking your DCU credentials and allowing you to use the Wi-Fi that exists in a campus. And what's cool about it is you can go to other educational institutes around the country, around the world, and if they participate in EduRoam, you get free Wi-Fi too. So a couple of months back, I was in California and walking by UC Berkeley, and up popped a load of Twitter messages, and I realized that I was getting EduRoam as I walked by. And about 2 weeks ago, I landed in the airport in Geneva, on the tarmac, in the bus, waiting to be driven to the terminal. I had Wi-Fi. No one else on the bus did. So it's quite cool. FileSender is a service that was developed by 4 of the NRENs, so the Irish one, the Australian one, the French one, and the Dutch one, SurfNet. And it's a way to send large files through your browser instead of over email, because nobody knows how to use FTP anymore, basically. And they use FileSender instead. And this is partially how we discovered the problem with the mail server this morning, because I sent the mail to Lorcan for my talk, and I was like, did you get that yet? And he's like, no. And I was like, what do you mean no? Why is this taking so long? And then we discovered the problem. Listserv is a piece of mailing list software. So this one is a bit, what's the word? Loved and hated. So some people really dislike it. We've run it and are one of the biggest listserv users in the world, and we've had it for about 25 years. So obviously we've upgraded it, honestly, in that time. It's a mailing list software, so mailing lists, you sign a bunch of people up to it, and then one mail is sent to all of them instead of multiple mails. We are a LEAR, a local intranet registry, which means that we allocate IP and IPv6 addresses to clients of HEAnet. There's no cost for that. IP addresses are free, which you may not realize if you get commercial services and they charge you for them, but that's how that works. FTP.dot, as I mentioned, is a software repository mirror that we host, which is largely SourceForge and Linux distributions and FreeBSD and all those kind of things. We have a desktop video conferencing service, which is like a better times 1,000 version of Skype. So it allows you to have a video conferencing session with somebody, and the quality is HD and very good. We do DNS, again, the forgotten system of the internet, along with FTP.dot. Without this, nothing works, and less people know how this works, so maybe that's a whole other talk for another year. But we host primary and secondary DNS for our clients. We host Anycast resolvers, so most people are familiar with Google's one 8.8.8.8, which means you can resolve a DNS address from anywhere in the world. We run one similarly for the academic community. And then EduStorage is a shared block storage solution that we host for our community as well. So it's a relatively cheap, solid, robust storage that is hosted in 2 of our data centers for resiliency. Any questions about any of that? Nope. So I was thinking about how I ended up in all of this lark, and one word I suppose is red brick, or as I remember it, red brick. And this was our new fancy logo, by the way, in the year 2001. We didn't have any such nice graphics back in the day. But why, how is this my introduction to my current career and role? I suppose it opened up the world of Unix in a way that I was being introduced to it in an engineering degree, but specifically FreeBSD and Solaris, which were what Red Brick were running at the time for the login servers. The command line, which I still love to this day and eschew all graphical user interfaces. Vim, which is a direct quote of, hey, how come your terminal has nice colors? And a slap. And IRC, the need to learn how to type quickly so that you can get your retort in as fast as possible to win the argument. Root, which is, obviously the power and how it corrupts absolutely. and networking. So how does this thing work anyway? I think more and more people just gloss over all of this, and they're glued to their iPhone or their laptop, and they don't really think about what is going on in the background at all. And it's quite interesting, I think, so hopefully this is encouraging for people. And just in case some people think Emacs is better than Vim, I think this really just solidifies that. Not just programmers, but sysadmins and network admins as well. So now I control the horizontal and the vertical, as Dr. Jolt, one of our founders, used to say. I am the manager of the infrastructure services team. So I'm just going to tell you a little bit about what we do. We're a team of 7 people. Lorcan's one of them, soon to be 8. We're currently hiring for a new person at the moment. What we do primarily is we manage HEAnet's data centers. So not to be confused with our POPs. POPs are points of presence where people come to meet to exchange internet traffic. Data centers are where your servers and whatnot live. The two can be the same location, but they're different in a way, and they're different from HEAnet's point of view in that we have many, many more POPs than we do have data centers. So it's a little quick glance into what our data centers look like. These photos are quite old, but not a whole lot has changed. It's basically rows and rows of cabs with rows and rows of servers in Blanchardstown and Park West. And here's my little nod to Stanley Kubrick by night here. And it's pretty hard to make data centers interesting, let's be honest, okay? There's not a lot that you can say that makes it sound sexy, but...
In fairness, a lot of work goes into making them not interesting.
Yes, indeed. And making you not notice that they're there is critical. This is our data centre down in Waterford. This is the research building down in Carriganore in Waterford. And it is hands down the prettiest data centre I've ever been to, because out the back of the data centre you were looking over the River Suir and green rolling hills of Kilkenny, and out the front you're staring at another building, which is what the offices look at, but the data centre looks out this way. So the data centre itself is obviously walls all around, because glass would mean extra heat and build up with that and air conditioning issues, but the people who work in the offices were the ones that had a hand in designing this building, and they made sure they had the good view for the data centre operations. So I thought that was very smart. What do we do down in Waterford? We host iCheck supercomputer, which is called Fionn. This is again, how do you make supercomputers interesting? It's really hard, but they are quite cool. They're challenging from the point of view of hosting them. This is 4 cabinets at 30 kilowatts each, which is a lot of power, in case you were wondering. Our other cabinets that I showed you there typically run at about 3.5 kilowatts each, 16 amps of traffic. So this is considerably more. In total, the supercomputer draws about 160 kilowatts of power to run. So there's another 4 cabs at 10 kilowatts supporting this. So again, back to the infrastructure team. What else do we do? So on top of the data centers, that's a considerable piece of work in and of itself. We run the network that connects anything that's hosted in that data center to the internet. I'm not going to bore you with any more network maps, so we'll just move on to all of the services then that run on top of that. And so for the infrastructure services team, the services that we look after are EduRoam. And for us, that means managing the national gateway service, which is how the authentication piece works. So here you are sitting in DCU, you connect to EduRoam, you send a request to the Radius server in DCU. It says, yes, you're a student through your LDAP login, and sends you back the right to connect to the wireless. You go traveling and you go to CERN and you want to connect to EduRoam there. You will try to connect to EduRoam. That sends a connection back to the Radius server in HEAnet as the national gateway, and that says, oh, you're a student of DCU, I'll send it to DCU's Radius server, and DCU authenticates you and sends back to you sitting in CERN, yes, let this person have Wi-Fi. So at no point is it sending your password or username in the clear, it's just sending the on-off authentication or no authentication. So it's all secure, as opposed to when you go and you fish for Wi-Fi, free Wi-Fi around, and then suddenly you realize you're getting all these targeted ads in your browser because you're sitting in a particular cafe and they're gathering up all your data. That's the beauty of EduRoam. We operate the layer. It's kind of a cross-team thing, but largely we look after this piece of it. We do a lot of work with DNS again. Both of these functions are shared across our team and the hosting team. We run the storage, block storage solution and all the fun that entails. We have a Git repository that is largely looked after by my team. We have a bunch of data center stuff, and I put this in here just to make Lorcan sweat, basically, because he is primarily responsible for these at the moment. But these are tools that we use in the data center. Rack tables allows us to just map all of the equipment at a cabinet level of exactly where it lives and how it's connected in. And DSView is our remote keyboard, video, and mouse software, so we can sit comfortably in our offices and not in the data center, and log on as though we're just in front of the server, either through the in-band connection or over console through out-of-band. So what that means is if any of you have ever played with firewall rules and locked yourself out of the box, you want to have another way of getting in to fix that problem, or you're going to have a nightmare. So out-of-band means that you've got an alternative link that you can come in and connect in on to make undo whatever change you made that was wrong and fix it. We also look after what we call LAN services in HEAnet. So basically this is the office IT infrastructure in HEAnet. My team are responsible for looking after that. And we are in the process of building an OpenStack cloud. So this is an ongoing project at the moment, but the idea will be that we will offer cloud services to HEAnet and to our community, so that people can run instances and do all the things that you do on the cloud, but have it be contained locally in HEAnet's data centers, so your data is private and it stays on network in HEAnet. So of all of the benefit of the cloud, that's one of the things that we see as something we can do that the rest of the public cloud people can't offer you. So, any questions? Yes?
You guys have peering to Google or AWS?
Yes, through INEX.
Through INEX?
Yeah.
I'm always wondering whether or not...
And Azure, don't forget about them.
I try to. I was thinking more that my DC email is on Google.
Yes.
So I was wondering whether or not there was a peer traffic to make sure that we're not paying for packet for that.
No, we peer, yeah. We peer at INEX. I explained earlier that INEX was formed by all of the ISPs coming together and sharing traffic. About 7 or 8 years ago, that flipped to being more about content distribution networks than internet service providers. So now who you see peering at INEX and why they're important are Facebook, are Google, are Netflix. And if you think about the traffic graphs I showed you at the beginning of this talk, you'll understand why that's important. We don't want to have to go over our paid internet connection to access those networks. We want to be able to get that data shared locally. And luckily they want to share it with us. So it has to be a mutually agreement. That's what peering is. So just to wrap up, we have intra-placements. This is how we lured Lorcan in, and this is how I was lured in long time ago. I should state as well, I think I was one of the first intra students in HEAnet, maybe second or third. So if you're in third year, or you're going into third year next year, because we've already done this year's one, think about applying to HEAnet. It's a pretty cool place to come work. We take on 2 to 3 students every year. Not all from DCU, I should stress, but if you're interested, we do post the jobs in time for DCU students to apply. It's a pretty great place to learn about networking, and you get really hands-on experience, which is not true everywhere. You know, even if you get to do stuff with networking in other companies, you tend not to get to go out to the data center and install the switch and plug it in and bring up the operating system and do all of that. And that all helps towards a bigger understanding of how it all works. So if you have any questions, just ask Lorcan. He's well versed in how all this works, but also please come talk to me. And finally, there's a really cool little article about the history of the internet in Ireland here. My talk, I guess, is going to be made available on the website afterwards, so you can click on that and see. And if you want to contact me, I'm still orly@redbrick.dcu.ie.
Let me just check that. I'll actually make sure you're interviewed.
It is. So, anyone have any questions?
How much would the traffic cost if it wasn't free?
I couldn't tell you off the top of my head what per megabyte the traffic is right now, but it has come down dramatically in the last 10 to 15 years. So it would have been our most expensive bill think of it as the worst telephone bill of your life, basically. And since I joined HEAnet back in the dark ages, one of the things we used to do when I was on Intra was run a top 50 sites to see where our traffic was going. And back then, it was Hotmail, and all the traffic was going over the internet to New York and to MSN, because Hotmail offered free. I really feel like a relic up here. Hotmail offered free email accounts, and DCU was one of the few colleges that gave students email accounts at the time. So a lot of our traffic was that, and we had to do part of the work that we did was in offering email, getting our clients to offer email to students to reduce that transit bill, because that was one of the key things. It changes all the time who's the main source of traffic. I'm sure a few years ago it was things like MySpace and things like that, but right now Facebook is considerably more. And when you consider the content that's being shared over Facebook, even based on what Facebook started out with, which would have been text, it's now videos, as they say, cat videos and baby videos and all that kind of stuff. So that multimedia content means more megabits, more traffic, to 25 plus gigabits of traffic a day. Yeah?
I think that kind of fits in. My question is, how long has it taken the network to evolve to that state, and what's the next step for HEAnet networks?
Okay, to the state where we run it as it currently is?
Yeah, so the ring network in Dublin, and the figure of 8 to the rest department, and then the bandwidth and capacity at which you run that.
So I'll go back to the graphs just to show. This one.
Yeah.
So again, when I started in HEAnet, we procured circuits to our clients from the likes of Aircom, BT, and whoever else was available, and they provide us with what were called managed circuits. So a 1 gigabit link or a 100 megabit link, just like your broadband link, to that site. And sometimes it was a resilient circuit. They'd built in resiliency into the circuit, so if somebody drove a JCB through one part of it, traffic would go around the other side. This happened more than I care to remember, so this is why I keep bringing up the JCB, and particularly happened to DCU as well when there was lots of building work going on here. We got the option in about 2003 to leverage the dark fibre of 2005, I think, to leverage the dark fibre that the ESB were putting all around the country, as I said, wrapping it around the high tension, the power lines. Most of the other times when fibre was put down, it was done so in Dublin primarily, because that's where there's the highest concentration of population. Makes the most sense from a commercial point of view of how you would do these things. But laying of fibre is expensive because they dig up the roads to put it down. And that's the part that's expensive. It's not the fibre, it's the civil works, it's the disruption to traffic. And if you've ever tried to go into town before Christmas and you see somebody digging up the road, that was probably us, so sorry about that, or by proxy are us. When we could get availability of this dark fibre, we looked at the option of implementing the optical network ourselves. So this is the, what's the word I want to use? Oh, I've completely blanked. We would have only run an IP network originally. So we would run an IP network on top of the connections that we would have got from the service providers, from Aircom, from BT, from UPC or NTL as they were back in the day, many moons ago. And I know they're Virgin Media now, I'm totally up to date on this one. We said, okay, on top of that then, in about 2003, we built our MPLS network. MPLS is a way of allowing us to build point-to-point circuits. So we would have only had the option from a cost point of view to give connectivity directly to DCU in one location. So you got a circuit and it landed here in the main DCU campus. But if they wanted to connect up St. Pat's down the road in Drumcondra, they had to buy another circuit themselves from whoever was available to give them that, say Aircom, and that was connected in. And then they came to us and said, we want you to do that piece too. We want you to connect all of our campuses together. So that's when we built our point-to-point MPLS network, which is what we call our blue net in our neck of the woods. Because when we were drawing these networks out, we had 3 coloured markers, and one was red, and that was the IP network, and the next one was blue, and that became the MPLS network. And then there was brown, and that became the optical network. So these things stick. You would not believe there's... so we still call it blue net and get confused when people don't understand what we mean by that. So the network is ever evolving, depending on the needs of the clients, depending on how things work. Most recent bit of fun is the government's call for the IoTs to merge. So you've got IT Carlow and IT Waterford are supposed to become one entity. In Dublin, I think Tala, Blanchardstown and DIT, I think, I forget. I could be getting that one wrong. Anyway, a couple of different IoTs in Blanchardstown or in Dublin are meant to form one single unit, and that causes networking changes that we have to adapt to and build. So, I'm not sure if I've answered your question fully, but what's changed for us has been that we've gone from just operating an IP network to operating a layer 2 MPLS network, which it's not quite layer 2, just for all the really hardcore networking nerds out there that are judging me right now. It's layer 2 and a bit, and then the optical layer. So we are at the moment, how this is going to change for sure in the next year or two. We have a tender that we're evaluating at the moment to wipe away all of the IP network networking equipment and all of the MPLS networking equipment and replace it. And that is called very lovingly ORMAN, the Replacement Metropolitan Area Network. We're great at coming up with names, in case you hadn't noticed. Edu this, edu that, edu the next thing. So that's really, I suppose, what drives the changes and what drives the network changes. But I don't think we're going to go back to not operating an optical network and not operating a point-to-point circuit network, because that's how we can effectively and cost-effectively deliver services to clients. And it's all easy in Dublin because the services are here. It's complicated when you're down in Galway and you're trying to connect the Gaeltacht sites that are out in Connemara, and they only had satellite links when they first came to HEAnet, which, if you know anything about transmission, is not good because the speed of light is a bit of a hindrance to bounce up to a satellite and come back down again. The other cool thing, I suppose, about what HEAnet has managed to do, as I said, we connect the schools. We've managed to improve the connectivity to the schools and connectivity in rural areas because we had these POPs, points of presence, in Galway, in Limerick and in Cork and Dublin. So people didn't have to pay expensive bandwidth transit connections back to Dublin to connect into HEAnet. They could connect locally. So a little ISP could set up in Galway and tender for the schools connections, and they would terminate in the HEAnet POPs. So this was a huge saving for the country, for your taxpayer money, I was going to say dollars, euro, to do this, because our network was leveraged to make these savings, to connect and to give better options for connectivity. So when the schools were first all connected, about 2,000 of them had satellite connections, which were kind of crap, because the alternative was a 1 or a 2 megabit line for DSL if you were lucky, but mostly there was no DSL outside of Dublin, close to Dublin. So if you were a school, that's not so good. You want everybody to have equal opportunities and access to these services. So.
Anybody else with questions?
Yes?
If you're on intro, what kind of work do you actually do?
Lorcan, make my coffee. No, he's never made my coffee, I swear. It depends on the team you're on, but if you're in the infrastructure team, you're doing a lot of hands-on work. You will be, whatever needs doing. So when Lorcan joined us, what needed doing was getting rack tables populated with the information. We'd set it up about 2 times, but never got to the point where we got the information into it. So he had the joyous task of going out to all of the data centers and documenting everything in every cab and putting that into rack tables and setting it up. You will be installing and upgrading switches and routers, no matter what team you're on, you'll be given that job. You get a lot of responsibility. We basically hand you the keys day one and say, don't break the car, please, which is a little bit terrifying, but also great experience because, when else are you going to learn how to do this? You have to try these things and you have to get hands-on with it. And if you're an admin for Red Brick, you'll know all about that. But I wasn't ever an admin for Red Brick. I was the entertainment officer. I did all the fun stuff. So when I got to HEAnet and was told, here's route, I was like, oh God, okay, I can do this. So yeah, there is no shortage of work. I think Lorcan can attest to that. And it's not all Excel spreadsheets and making coffee for people. It's interesting work. it's hands-on.
You get some kind of interesting projects, like I was tasked to analyze the log of the FTP server, so you get to see where the traffic is going and how many bytes it downloaded to particular countries. Could go over there, but already has it.
Yeah, it's too late. Any other questions before we let Orla actually sit down? No, Kevin Esoteric has just pointed out a link about the fiber over ESD if anybody wants to check it out in the IRC channel.
Actually, yeah, there's a cool video where you can see them wrapping the fiber around, which is probably what he's put in there.
Exactly what he's put in there.
It's good to know he's watching back in the office. It's good to see somebody's on the stream.
He's supposed to be working.
It's quite a cool video because it's just so, what's the word? Basic. It's like they've attached a lawnmower to the fiber and it spins around in a circle traveling along the wire, but it's really cool to see. So again, a crazy engineering solution that has saved the country thousands of euro, hundreds of thousands of euro, because we're not doing civil engineering works, digging up the roads and putting them back down to lay fibre all around the country. So we're using what's there and making use of it for future uses as well.
Actually, really good question.
Yes?
Standout moment in HEAnet to date. What first cool thing that pops into your mind?
Oh God,
At least.
this is like the worst interview ever.
No.
Oh, I have no idea. This morning being right about the network not being broken.
True root holder.
I don't know. There's lots of cool things we've done. I mean, this will not go down well with Tiernan, but HEAnet has, for a long time, done things that probably wouldn't make a lot of sense, but with a long-term plan. So tenders that I've been involved in for getting our transit connectivity. When I joined HEAnet, we had a link via the Atlantic Ocean to MCI WorldCom in New York. We were based in the Twin Towers. So when they were attacked, we had no internet connectivity, because there was one of my favorite things about being a network engineer is the tickets that come in from transit providers when there is a crisis, and not particularly in this case, but it just brings it home how this all works on a basic level. So HEAnet, the pan-European network, have built and operated networks in other parts of the world where they wouldn't have the knowledge and the know-how to do this. So in Southeast Asia and in Africa and places like that. But Southeast Asia particularly was my favourite. When I came back to work in HEAnet in 2005, there was a new network was being built called TN2. And Southeast Asia, a lot of it is islands connected together by fibre, and when there was a fibre break, the ticket would be a very long piece of about, we've sent divers out in the boat, they can't find the other end of the fibre, they've come back again. We've sent divers out in the boat again, they can't find the other end of the fibre, they've come back again, it's been too stormy, and it could take up to a week for them to find both ends of the fibre, bring them up, join them together and lay them back down again. And to me this was like the worst soap opera ever, but in a really good, exciting way, because again, like the engineering challenges about how you lay submarine cables and how you stop fishing trawlers from dragging their anchors through them and pulling them up, and these are quite interesting. They electrify the fibre on the seabed, not for any technical reason, because optical doesn't use electricity, it uses light, but they electrify it to stop marine life from going near it and chomping through it or doing things like that. So it has a very low current to stop that, and obviously to help detect where the fibre is laid. So there's some really cool, if you're interested in it, I guess I can post links about it as well, maps of submarine cables connecting up the world, basically, the way that there would have been for telecoms 100 odd years ago. And they're fascinating as far as I can see. 5 years ago, Africa only had internet connectivity through the Suez Canal, going down along the eastern coast of Africa, and Somali pirates continually kept ripping that fibre up, and all of Africa would be cut off from the internet. So there was a long piece of work and projects by the South African NREN to bring connectivity down the west coast of Africa, which is much longer and much more expensive, and to connect up all those countries. And these things have social issues associated with them. It's not just about technology. If you can't get access to internet, you can't get access to a lot of basic services. We sit here in total luxury talking about Netflix and Facebook traffic, but like if your whole continent isn't connected to the internet, that's a big problem. You're never going to overcome poverty and diseases and all that kind of stuff, because you can't get information effectively shared. So it's hugely important in that respect. Okay,
Cool.
that's me. Okay, thanks very much.
Applause